Good evening, good morning, good afternoon, everyone. Welcome to the next episode of Groundbreakers Transforming Geotech. And today we have Mr. Hamzah joining us, who is a geotechnical engineer by study, and he's specializing in geotechnical design and remote sensing, and is currently the regional manager at GeoFem based in Bahrain. And he is also currently pursuing his PhD from IIT Mumbai. So you're going to get a lot of depth, knowledge, and experience in the geotechnical realm from Mr. Hamza today. And thank you so much for being on this episode with me. And I hope that we can give our viewers something new, something exciting, and something enriching to learn about. And I think we can start off by just give me a overview of your career journey, what motivated you to be in the geotech field, and what have you seen really evolve in the past few years?
Thank you, Geotech. It's really awesome to join you in this episode, and I have been following your series, I would say, and it is really nice initiative from you to group this small community, as you said, all together in the geotechnical and instrumentation monitoring in our field. And thank you for the introduction as well. A brief about my journey. To be honest, I haven't selected or opt to be a civil engineer, but I did opt to be a geotechnical engineer. I remember in my undergraduate where I got a scholarship in Africa in a civil engineering, and I came to know about the geotechnical engineering that our other professors in civil and structural engineering, they used to know, they say there is no much of development in structural engineering. It's 1 + 1 = 2 all the time. There is no unpredictable. So I felt that kind of boring, to be honest. Sorry for my structural engineers colleagues, but in geotechnical engineering, there is no site like the other sites. There is no, even within the same site, there is no borehole similar to another borehole. It's a ground of unpredictable uncertainty. So we are not sure what we are measuring, how we understand the soil. Till this moment, there is no comprehensive model that capture all aspects of soil. So that kind of grabbed my attention, and I decided I want to peruse in this field. After my graduation, I was lucky enough to start and join a geotechnical investigation field. I was involved in geotechnical investigation reports, field testing, lab testing, the SPT, pressure meter, CPT, and those kind of tests. It helped me really to understand the soil more closely to some extent. After 5 years, I perused my master degree as well in geotechnical engineering because I wanted to know more and more about the geotechnical engineering. But there was a turning point where I joined geotechnical and structural contractor, to be honest, and only then I came to know how important the geotechnical engineering to the other field. Because when we were in soil investigation laboratories, unfortunately, we are somehow isolated from the other loop of the project. So they think that they need from us the soil report, small recommendations, what is the building capacity, and that's it. While when I moved to the structural engineering and construction firm or field, I came to know this is only the starting point. The soil report is not the end, it's just the starting point in geotechnical engineering. And everything comes or starts from there. In that sense, I could connect the geotechnical engineering with the structural engineering, the soil structure interaction, how our parameters or recommendations matters and affect the projects. And finally, I moved to after another 5 years, I moved to the consultancy field in geotechnical design. And currently, as you said, I'm perusing my PhD program. So that's in a nutshell, I would say, my journey.
Wow, that's a long journey, and I think you've got a touch in almost every aspect of the field that someone can. And it's very interesting.
Hopefully.
Talked about the unpredictability of the soil because I remember I think our first rock mechanics lecture, Professor Zekos was like, there's one thing that you need to know that everywhere the ground is different. And I think that's something that really is like, wow, because everyone thinks that it's a building, it's another residential complex, another metro, but the complexity really starts when you really realize that there's so many more parameters that go into this, whether it's on the construction side, the 1+1 in the structural engineering, or even the site investigation reports. So I think that's great.
Exactly.
And you've also been involved in a couple of high profile big projects like the high speed rail, like the Riyadh metro. So when it comes to young engineers, how would you say that these projects work? What have been some of the challenges you faced as a geotech? And what are some things that you learned?
Well, it was a really significant learning process joining in these mega projects, I would say, because you you will encounter that it's not a one-man show, or it's not one field show. It's not only about geotechnical engineering or civil engineering or mechanical. Um, the problem or the challenge was always multidisciplinary. There is a lot of fields and engineers and teams encounter together. But the main challenge, I would say, was the communication among those teams. I came to see many of the problems where I can on site, because the lack of communication, for example, between the site team or the design team, or between the geotechnical team and the structural team. So there is always a lack of communication. And I think that was the cornerstone for such kind of problems, to enhance what we know now as a digital twinning and BIM and monitoring and integration. So because previously there was a lot of data, there were a lot of data, but it's of no use. It's archived, it's in dusty files, and nobody used them, nobody integrate and connect them together. So that, I believe, was a cornerstone to enhance this integration in our field. So I believe that was one of the main challenge. Another challenge for young engineers, when I started young engineers, of course, that if you are seeing something going wrong, or you want to advise or apply what you have learned in the field, there is always this age limitation, because they used to have this stereotyping of seeing a gray or white haired guy. He will advise, or he should advise, while you should be a listener. But my simple and humble advice, that don't fear out of speaking what you learn. Everyone has a different perspective, a different angle, how he or she is evaluating the problem. So just be confident and share your information, share your knowledge, and keep learning. We are all keep learning. There is no end, especially in geotechnical engineering. Again and again, 1+1 = 2, but not in geotechnical engineering. It could be one day we wake up and we discover something new, and 1+1 might be equal 3.
Yeah. Yeah. And I think that's very good advice, especially the second part where you're saying that like speak what you think is correct, and you're always learning. And I think that's something very important as we progress in our careers. And about data, one of the big motivations for our team to start Procure again was that lack of data, lack of communication, to really bring it together, that it doesn't matter if it's a digital twin or a UAV or InSAR or sensors. People need to be informed, and people need to know that, this is what we're doing, and really solving that iron triangle of value, time, and cost, and balancing that out. Because I think if we figure that challenge out and really give opportunities to everyone, it'll be very, very progressive in our field as well. So my next question is that at GeoFam, you're doing InSAR monitoring as one of your major roles. And could you explain this technology to some people who are just hearing it as a buzzword, and like what it is, how it's helping projects, and how it can really add value?
Sure. So when we usually refer to the satellite and remote sensing, people usually they tend to link it with imagery or Google Earth images and optical satellites and those kind of stuff, and they wonder how we are using the satellite to monitor the ground. But to be honest, InSAR satellite remote sensing is one of I'm seeing the development and the technology or the construction field start to recognize its importance. but not yet fully appreciated. It has so many capabilities and applications and advantages that yet to be utilized in the construction sector and the construction engineering field. Imagine that if we have the ability to access any location on the ground, remotely from the space, not only in the present time, but we can go and travel back in time. So we call it sometimes internally in Geofem, we call InSAR as the time capsule, because when something goes wrong, and unfortunately, this is also a bad habit in the practice currently, they do not realize the importance of the monitoring unless a problem happens. But the monitoring system should not be used on that basis. It should be proactive, not reactive system. You should adopt monitoring system before anything goes wrong, because if things can goes wrong, you can avoid it, or you can learn from your data and enhance the other projects and keep an eye on your projects and assets. But let's say if something goes wrong and you didn't, unfortunately, use or utilize monitoring system, the only option, I would say the only or one of the only options available is the InSAR satellite remote sensing, because with that tool, you can travel back in time and see when this problem, let it be a slope stability failure or excavation failure or deformation of a building or a ground or a foundation. You want to know what causes it, what derives it to fail, and what could be the reasons behind it. So InSAR will be one of your asset to identify and evaluate these. And a lot of people surprised about the accuracy, because they think it's thousands of kilometers or meters away above the ground, how accurate it could be to capture the deformation and the monitoring. But the answer is quite shocking for the people outside this field. Its accuracy is usually between 1 to 4 millimeter in terms of deformation and movement accuracy. And the spatial accuracy, it varies as I don't want to go too technical into this. I don't want to bore the people, but in a nutshell, that the accuracy of InSAR satellite remote sensing is quite accurate, from 1 to 4 millimeter. It has been validated by national and international scale, because as you know, that many of the satellites that utilize InSAR is public satellites, available for everyone, available for free. The major or the most famous one is Sentinel-1, for example, from the European Space Agency. So anyone is free to use it, but how to use it, what skills you need to analyze and interpret and read the data out of it, this is the skills we are adopting in Japan. Yeah.
I think that's a great explanation. And I think 3 points stood out to me. One is the importance of monitoring, whether it's through InSAR, sensors, total stations, or GNSS, because all these technologies are evolving. And with InSAR, you get millimeter level accuracy. With GNSS, you get that as well. And it does work as an early warning system. So you would rather have it. It's like your life insurance today, right? Like you want your life insurance, but you never want
Yeah.
to claim it. And I think the second part was that with more satellites launching, and the key thing that you said about getting data from the past, right? Because you do learn as the site movement changes. You do, like, even with our inclinometers, we see how construction is progressing. We see how the lateral movement is happening. And with InSAR, you can actually go back years in time. And then if you do a bit of time series analysis, you can also give a suggestion predictive in the future. So it's actually like time traveling on a construction site. So the value of remote sensing really, really is coming up. And I feel like you'll have data every day in the next 18 months to 2 years with the amount of data that's coming. And when you couple it with InSAR, with ground-based sensors, with surveying, and with other different types of satellite data that we're hearing about, like hyperspectral, you really get that layered approach, and you really get every single aspect of your construction site monitored and linked to your construction schedule, progress, etc. So I think it was a very interesting overview, and now people know slightly what InSAR is: satellite monitoring, giving you millimeter level accuracy about the changes of your ground at any point where you can access the data from. And it's available for free. So if you want some tips on how to analyze, you can always reach out to Hamza and he can help you.
Yeah, sure. And exactly what you have said about the coupling, to be honest, this is the key aspect of the monitoring solution. Like everything else, like in medicine, there is no one solution fits all. There is no one medicine fits all. So in geotechnical engineering, it's pretty much the same. There is no one ground improvement method that fits all the projects.
Yeah.
There is no one type of foundation fits all, and there is no one type of monitoring fits all. But coupling between those technologies would provide the most valuable asset to you, to a team in a project, to a client, to an owner, because no matter how we speak about how good InSAR or remote sensing is, but there are limitations, of course, for each and every technologies. And I might bring some examples about those technologies and limitations and challenges as we progressing in this talk.
Yeah. Maybe we can go ahead with that if you want to continue the con.
Awesome.
Yeah.
Awesome.
Yeah.
Awesome.
Yeah. Let's
Awesome.
do that.
Yeah, so I do remember in one of the projects in the Gulf countries, in one of the Gulf countries, it was an embankment recently constructed and for a bridge, for a highway bridge, and not it doesn't take much time to recognize there was failures and cracks occurring on sites and deformation, some kind of lateral movements as well. And they were not sure what went wrong in that. And we was not sure as well. We were not sure what are the reasons behind it, because on papers everything looks all right. The design, the soil profile, everything was okay, but we still couldn't figure out what could be wrong, and we didn't understand as well the trend or the direction or the exact magnitude of the movement. We just have visual inspection, some sort of survey, on land survey, but of course that doesn't give you much of an information. So we decided to use in-situ monitoring, and it was a big, hectic process to convince the client, to be honest, why they do need in-situ monitoring. They said, no, what is the reason? Please go and solve this problem on site and fix my cracks. We told them, no, we don't really recommend what we call it makeup repairs. So it's that just superficial repair, and the problems will keep occurring unless you understand the root cause of the problem. You will not be able to solve it. And this is very important, especially in geotechnical engineering. You have to understand what caused this failure before you attempt and solve it. So after many discussions and meetings, we convinced them to use some of the in-situ monitoring. It was inclinometer,
Mm.
extensor inclinometer as well, to be able to extract 3D dimension. But again, the main challenge was where to place them.
Yeah.
We have like 100 meters or a couple of 100 meters of embankment, and where to place them, they allow us only to install 2 devices. So it was, we did our best, but it was kind of a gamble to decide where we could place those two efficiently to get most of the information. That was before I joined Geofilm and came to know about the InSAR remote sensing and this kind of technology. And now I can relate, if we had an access for such kind of technology, we could run it, the InSAR, and as you said, we can couple it with other in-situ monitoring, like in this case, the inclinometer, and we can identify when we do the retrospective analysis of the InSAR. We can see in the past when this issue was created and where, and we could optimize the layout of the InSAR. And I believe we could convince the client more easily that no, you need more than two, and you need it in this location and that location because you have problems here and there. And by that, we can couple both of the technologies for one goal to solve the problem of that project. So that was one main and clear example for me how both technologies support each other's, the in-situ and the remote sensing.
Yep, I think that's a great example because you'll also get to compare both types of data, right? Like You're getting settlement from InSAR, you're getting settlement from a inclinometer with settlement or an extensometer. And you actually see that like this is the difference, this is what's actually happening. And then when you couple it with maybe a laser scan and put it on the digital twin of your asset, you can really get that whole feel of your infrastructure. And I think that's something that will really help engineers as well, because right now in our industry, I think in the little 6 months that I've been out there, I've been seeing a lot of people still use Excel. A lot of people still have 10,000 graphs as engineers on site. And it's tough for them to really be like, this point is this point is that. But if we give them that tool where it's like an analysis tool where they can really easily know that, this point there's an issue, go check it out. This is the trend on this point, everything's okay. And then you go to another level and you go to an asset owner and be like, with all of these technologies, it's like a restaurant. You pick what you want, we'll give you our suggestions, and you start monitoring. And based over time, we can always increase the amount of monitoring. If it's all good, you don't need more monitoring. If there's an issue, let's monitor it, let's take action now. Whether it's from a drone or from InSAR or from a sensor, it does not matter. But let's make
Yeah.
everyone safe and let's make the construction process smooth. And yeah, so I have a follow-up question. So there's a lot of old infrastructure, like especially in the US, there's I think out of the around 90,000 to 100,000 dams, most of them are under high risk or significant risk. And even we have a lot of heritage sites globally. So how do you think remote sensing there can really, really benefit people who are looking at maintaining the infrastructure?
Awesome question. Because indeed, not only in the US, also in our regions, me coming from the Gulf region and the Middle East and this part of the world, we do have, as you said, a lot of old structure, ancient and heritage, a lot of UNESCO buildings and sites that are massive and huge in area and in amount of the buildings need to be protected. And we have seen many failures took place. Even I believe there was a residential tower, I believe in California, if I'm not mistaken, last year. It was collapsed because it exceeded its design life and there was not enough inspection and not enough monitoring for it. And still there are arguments what are the causes or the root cause of the problem. But I believe the coupling between the different technologies available for the in monitoring for those kind of sites is essential to avoid such kind of failures and problems on site. Because on one hand, it's not really practical and it is costly to cover all the buildings in those areas and all the area with in-situ monitoring. We can fill it, all the buildings with the strain gauges, with tilt meters, crack meters, but to be realistic, who gonna pay for it? The municipalities, the landowners. It's always a dispute between the different stakeholders and parties who should pay for that. And still, unfortunately, still in many of these occasions, the monitoring is not yet appreciated because, yeah, okay, monitoring, we can use it, but the mentality is still that we can send someone to inspect it visually and give the engineering report, no, this problem, there is no problem, or you need a strengthening here and there. But unless you don't know the details of the movement, the details of the deformation, how it moves with time, how it deforms with time, how it behaves with time, you will not be able to solve it. And using a coupling between those techniques, you could optimize, reduce, and use them efficiently to reduce the cost, but yet don't compromise on the safety for those structures and buildings.
Yep, I think that's a good way to put it together. And it is super important to really, I think one of our missions here is also to educate not only young engineers and motivate them about the field, but also raise our voice to the people who are making these decisions that, you know what, we're here to help you as different companies working together as well, even if we're not officially working together. Because at the end of the day, what really matters to all of us in the community is the safety of our structure, safety of our residents, and safety of our communities. And I think the best way to do it is through monitoring until we have another breakthrough like AI coming in our field or something that we don't know. So bridging onto that breakthrough. So remote sensing is coming as a breakthrough. IoT is coming in as a breakthrough. Digital twins, even though they've been there for a long time, are now becoming a big buzzword in our industry. So how do you see these different technologies, or if I missed out on any, really helping us become more efficient and progress in our field of monitoring and construction?
Yeah, exactly. Actually, as you said, this there are trend or booming in the use of these terminologies, the digital twinning, the BIM, the IoT, IIoT. But that didn't came out of blue. It was, as I mentioned before, it was years of struggles of disconnected data, archived data of no use, and there is a huge, especially when we come to ground engineering and monitoring and structural health monitoring. There are huge of data available every year, and different type of data from the ground, from movement, precipitation, temperature, strain, deformation, movement, stresses. But they are all, unfortunately, not let's not say all, but most of them are of no use because they are not connected. You can interpret and analyze each of type of these data or each set of these data individually, but no one were previously coupling all of them. Most of them, a few of them maybe, but all of them to be connected and help you to decide according to all of these data integrated with each other's. It was not there simply, and that was, I believe, the main drive to move towards the digital twinning and BIM. So it's not just a fancy word or a technology we want to apply to our project. No, it does really help us to understand, as you say, the big picture. We need to step back and see the whole picture and understand the whole situation and the whole behavior of not only my asset, but how my asset is affected by the other assets, by other construction activities or projects going nearby, the climate change, the geohazards now is a big issue we are facing worldwide. So all these kind of stuff, the key solution is monitoring, because as the for myself, being a lead green associate as well,
Yeah.
I like to quote that from the US Green Building Code or practice guidelines, that you cannot control what you cannot measure. So it's really nice quote, because it is true that if you cannot measure it, you cannot control it. If you
Yeah.
don't monitor it, if you don't know it, you cannot control it.
Yeah.
And that's simply it is, yeah.
Yeah, I think that's a great way to tagline the podcast. Now, if you can't measure it, you can't control it. And today we do
Exactly.
ways to measure it, and then we can take action to control it. So I think my last question to you is that we've talked a lot about different technologies, the importance of technologies. We've talked a lot about geotechnical. We've talked about your experiences. So for a young kid still in high school or still in college studying civil engineering, what would be your way to tell them that, you know what, geotechnical engineering is cool and you should check it out, and maybe monitoring and BIM as well?
Yeah, awesome. Before jumping to that, I just remember one point I wanted to
Yes.
highlight, because when you said it's our job not only to do the right things, but also to educate and increase the awareness, and that's actually true. And one part of, or the major part of this responsibility, I would say, it comes to the regulators, to the standards and guidelines. Authorities and communities, because I believe in one of my discussions with an insurance company in Germany, they mentioned to me that they encourage monitoring in the construction field in Germany, and they do have some advantages or privilege for the people who adopt monitoring in their buildings and assets. if you use a monitoring or adult monitoring of any kind in your project or in your asset, they give them privilege, like in terms of a discount or discounted insurance or more comprehensive insurance, which is really good, because without, in certain cases, we can, yes, do our best and educate and increase the awareness of the public. But at the end, you need a regulator body. From my humble opinion, you need to strengthen your perspective and point of view with a regulator body to tell them, at least encourage them, at least give those people who adopt and appreciate the importance of the monitoring, you will get an advantage, because it's not helping you only, it's helping the whole country. If, God forbid, something collapsed, if a private residential tower collapses, it's not only the owner of that building who will be affected, it's the community, the society, the people who live there, the people who will live around that, and the country, and eventually the whole globe will be affected. So if we start from this to the globe and start appreciating the monitoring, then we will come to see the real benefits and the advantages of the monitoring system. Now, moving to your question about the young and future geotechnical engineers, well, if you guys still didn't recognize how cool the geotechnical engineering is, just think about what I have mentioned earlier when I said that 1 + 1 = 2 in structural engineering, but and other type of engineering. In geotechnical engineering, it is not. It is it's a mystery. It's a mysterious field. It is uncertain. A lot of uncertainties in the ground, and I would use a quote I learned from one of my professors in the master program. He told us to encourage us appreciate geotechnical engineering more. He said, understanding the soil and the soil mechanics and the geotechnical engineering and ground is understanding human, because we, after all, we have been made out of soil, out of dirt. So think in that perspective, that because we are just like the ground, we are heterogeneous, complex, uncertain, unpredictable as a human being. So that's also applicable to the ground engineering, with all due respect for all the other type of field in the engineering spectrum. As I said, there is no one field show or one-man show or one engineer show in any projects. It's all cooperation and teamwork among different teams, different fields, and everyone has his important role. But if you find your passion in geotechnical engineering, just follow it.
Yeah, I think that's a brilliant, brilliant way to end it. And there's been a lot of inspiring quotes, great insights, and it's been a pleasure to have you on our podcast, Hamza. Thank you so much for your time, and I look forward to another episode in the future to recap and see where the field has evolved and for you to share more experiences, of course. Thank you so much.
Thank you. Thank you, Ravitek. My pleasure. And always remember, if you cannot measure it, you cannot control it.
Yes. Thank you.
Thank you.